Hello everyone, welcome to the HCIP OpenELDR certification course. Now, let's continue to learn about OpenELDR storage management. In the previous course, we used 3 ECS to perform NFS experiments on Huawei Cloud. We also used 3 ECS to complete the network experiment of SAN storage. We are using SAN storage in the experiment, so we still need to install some components of our SAN storage. So let's experiment with it again. We still use mobile software to complete the login, and I have already logged in. So I'm not going to show you the login process again, and once you are logged in, let's together to finish the experiment.
Now, let's take a look at the experiments related to SAN storage. First, its network is similar to the previous NFS work, requiring 1 server and 2 clients. And step 1, we need to install iSCSI on the server. As a target, the server needs to install the target components. And first, we need to install the SCSI target, that is SCSI-target-utils installation package, which is a component we need to install on the target. Now, after the installation is complete, you can run the rpm command to query the download status of the corresponding installation package. And here in the lab guide, it used the rpm-ql command, where -q represents the query mode and L represents the file in the packet. Therefore, when we're using it, we need to write the full name of the component we just installed through YAM. That way, we know which files we just download. So here we run the rpm-ql SCSI target utils command. And after query, we can see that it has downloaded a lot of related component files. And then we are going to start them, and then we are going to set them to start automatically, which is the same as the previous operation. And here, we notice that the startup service of the target is tgtd.service, which is different from the NFS. Because NFS can directly start the NFS, but the target, that is the tgtd.service. And then we set up the auto start. And here, I enter the tgtd directly instead of the following .services, which is the short expression of it and also can be used. And then let's check the status. Now we see that his service has been started. And it has been set to start automatically. After query the service status, let's check the port status, and we entered the net state, followed by -tnlp. It is used to query the port status, that is listening port status. After press enter, these are some of the port information we use. In fact, there may be many ports. For example, 3260 is marked with TGTD, which is the listening port of the target. And then 111 is the RPC bind we mentioned earlier. Therefore, we can query the status of their ports and whether they work normally. And if there is too much content displayed in actual situation, we can also use grep to filter it. So we can filter the port number that only contains 3216, and we can see its TCP using TGTD. And after querying the status and port status of the corresponding server, now let's create a target, which is similar to the shared directory created in the NFS. And the command for creating the target is very long, therefore you must be careful when entering the target command. And the target-related command is target-admin, which is short. We can use at tgt-admin. And then we enter ~LLD, which represents the underlay logical driver. That is, the target is created by the underlay driver. And here today we will use the iSCSI in this lab, so I have to enter iSCSI. And now you can see it's turned to blue. This is an action option. It's marked by blue. And then we continue to create the target. So we need to type ~mode, which specifies the operation mode as target. So now we type target. And then because the target is created now, so you need to enter its mode when creating the target. The mode is called ~OP, and then which is the new created. And if the operation is delete, we enter delete. And then we change to new. Then the target has the ID because the server needs to create many targets to provide services for different devices. Each time one target is created, an ID is generated. So here we need to enter the target ID. The first one is 1 and the second one is 2. And this ID is used as an identifier on the local server and is unique on the local server. And then there is the name of the target. And here we can type a very complex name, or also we can just by ourselves give a very easy name. And here we type ~target name. And then I will give them the name for IQN. For more easy to remember, we change it to IQN.2024 as a name. And then we press enter. Now we have finished create a base target. And here we have a little trick you can pay attention to, that is when we type a command, we enter "LLD" mode in this type. This is the way the full command is written. Sometimes you can also use the short name of the command. For example, "LLD" can be used by "L", and "mode" can used just for "M". And here is some various command that we can use to type, and also we can use " for help to check the full name of the command and the short command. And now let's take the target we just create as an example and test the difference between long and short commands. And first, let's try the short commands first. First, target admin and then enter "L", and then iSCSI and then the mode "M", and enter the target, and then "OP", we change to "O", and then show. In this way, we can see the created target IQN.2024. It's the name. And it's just there is nothing in it, just an empty shell. And then let's try the full command, the long command. For example, tgtt admin and then "LLD", then iSCSI mode for "mode", and then target "OP", and show. This is when we find out that they are the same. They are the same information. So by this test, we know that the double dash is capital L, and we notice that it must be capital. And then "M" indicates mode, "O" indicates OP. And currently, no LON has been created in the target. The number of LONs is 0. Therefore, we need to add some LONs to the LON. To add a LON, a disk is required. Add a disk as a LON. It's important to note that here that is the disk. It's better to use a separate disk. So we can use fdisk-l command to check the local disk. As you can see, there is a 40 gigabit disk and another is 11 gigabit disk. The 40 gigabit disk is a system disk and 11 gigabit disk is an extra added data disk when we create the ECS. And here we can mount it as a LON. To add a LON, we run the tgtadmin target admin command and "LLD" iSCSI and then "mode" command to create a new target. In this case, because we do not need to create a new LON, therefore we need to add a LON to the target. So therefore, we need to write the LON into the logical unit. This logical unit is a logical storage unit, which is the storage device in the target. You need to add the LUN to the logical unit so that the LUN can be identified by the server. So here we set it to logical unit. And then continue to use "-op mode because we want to add this disk to the target, so the mode is also new. But notice that the first time we use is new target, and here is different from here, it's a new LUN. And then we need to add a new storage media to the target whose ID is 1, that is the TID1, and add a new LUN ID. For the LUN ID, we enter LUN 1 starting from 1. And now we want to mount the disk to the target, so we need to select the backend storage, and we enter --backend store. That is, the mode is backend storage. Actually, the block storage generally select this. And then we write to the disk, which is DV and VDB. The name of the disk device is the name of the disk that you need to add. After the fdisk command is executed, the name of DV-VDB disk is displayed. So here we use this one. And now let's summary. The logical unit is a logical unit of the storage system, and then new command to add LUN 1 to the target whose TID is 1, and the disk name is DV-VDB. And after the target is added successfully, we check the target information. Okay, we can see that the number of LUNs is 1. And the size is 11 gigabit. So now we have a storage space that we can use. However, although we already have the LUN, but we have not configured the account access information yet. So the share cannot be configured at this time. Therefore, first we need to configure which client can access us, which is the same as the IP address access configuration on NFS. So we enter tgtd admin and L for iSCSI. And now we need to configure which IP address is used for access. Therefore, the operation mode is target. And now we need to bind the IP address to the target. Therefore, the operation is binding. So --op bind is specific initiator to connect to iSCSI. And then we enter the ID of the target. And finally, its IP address. And if you do not memorize all the command during the command input, you can directly press enter. And now the system promotes the correct command options. And they complete the command line according to the system prompts. Okay, after finished, let's check it again. After the bounding operation, in this case, the ACL access IP address under line 1 is displayed at the IP address of client 01. In this way, the client IP address is 1.75 is bound to the server target. So far, we have finished configuring the SAN server. Now, let's look at SAN storage server configuration. As we mentioned earlier, the client is different from the server. So, what is it installed on the client? First, we use yum install iSCSI initiator utils. It's installed with iSCSI, which is the utils of an initiator. On the SAN storage server, the utils of the target is installed. So the two components are different. After the installation is complete, we need to start the system as usual and then start the system automatically. And in this, as I am a client, so we just start the iSCSI service. And after it starts, we set it start automatically. Enable. And then we check it. Here we can see that its service has been started successfully. So after the startup is successful, connect the local client to the removed target. What should we do to finish the connect configuration? When we initiate a connection, we use the iSCSI protocol. So let's enter iSCSI admin, which is used to initiate our iSCSI. And then we enter -m to indicate the iSCSI mode, including discovery, basic operations, and query sessions. The connection has not been established yet, so it is the removed discovery part. Therefore, the discovery operation is performed. And then I find the removed end, enter -t followed by the sent targets, and then enter the IP address 1.6. This IP is the address of removed server you want to discover. And so let's see the name of the target we create earlier is the same here, IQN.2024. The port number is 3216. And after we discovered is complete, we continue to connect with it. iSCSI admin -m, but what should the mode be set? Previously, we used the discovery to discover the removed end, and now we need to connect to the removed end. Therefore, you need to enter node to connect the discovered node. And then we can directly enter all. So all information I found earlier is loaded. And after loading, let's check. We use fdisk-l. At this time, we'll find there is an additional 11 gigabit disk, which is DV-SDA. But the disk on our previous part is called VDB. The two names are different. Why? This is because the VDB is the newly disk created when the ECS is created on the Huawei Cloud. At this time, the disk is discovered through the iSCSI protocol, so it's an external hard disk. So that is the SDA. So we can see by its name that this one is our new added one. It means that my mount is connected successfully. So now let's go to the server to query the status of the target. Let's take a look at what's changed. In there, an extra IP address in it. So what's this? This is one of our initiators, which is our client. The IP address is 1.75, which proves that it's connected and ready to use. So what if we want to demap? We just need to terminate the iSCSI connection. So you can run the iSCSI admin -m and then node to delete a connection, and then we use -t to delete the session information. And then you need to write the name IQN 2024 and then -u. So I unmounted the disk. And let's check. When fdisk is executed, the SDA is gone. So in this case, the iSCSI connection is closed on the client. And if you want to reconnect, we can reconnect it directly. Discover first, and then reconnect. And then we find the disk is back. So it's convenience. And so is there any simple way to do this? You can also run the iSCSI admin -m and then session -u command to delete all the commands. In this way, all iSCSI connections are deleted. Because we have only one connection in this part, so you can also run this command. However, many iSCSI interfaces may be mounted at the same time on the live network. Therefore, to delete a connection, you can use the method of deleting a connection described above, just one by one. Please do not delete all connections one time. The preceding information is about iSCSI mounting, uninstalling, and viewing sessions. And now we need to operate on this disk. So when we get a disk, we need to format the disk and partition it. So we need to format a disk first. And here we run fdisk-l to query the disk name. Ensure that the disk name is DEVSDA. So let's format it. We format it in ext4 format. After the formatting is successful, let's check it. Here you can see the format is ext4, and then we can continue to use it. And now we need to create a directory and mount the disk to the directory. So first, you need to create a folder or create a folder and also create after the mount send. and cd to the folder and find the folder exists, and then we mount it mnt sun. After mounting is complete, we can run df-h to query the mounting status. Now it's successful. And then we need to create a small file in this folder, which is now empty. And we use the touch command to add a sun.txt file. And in this sun.txt file, we can write something. For example, client 01. And then we save the file and run the cat command. Here the client 01 is displayed. So there is a small question that you can think. Can we see this test.txt on the sun server? In fact, what we provide is a LAN, which is a storage space, so there are no folders in it. This is different from the NFS disk path, where the contents of the value are not visible. But at this point, what if I want to view it? It's simple. Let's find another host to use client 02 to view the target. So on the sun server, we add another client. We run the target admin -m, and then we select iSCSI target, and then add a new IP address. And then bind the IP address TID1. Initiator address, the IP address is client 02 IP address 1.143. After the configuration is complete, we check whether 1.75 and 1.143 can be accessed. And then we need to access it on 02, which install the components of the client. So let's install the initiator with yum. And after installation, we start the service. After the service is started, we connect to the iSCSI server. Now the status is active. And then we connect to iSCSI server. 1.6 is the IP address of the server. And then the server can be discovered normally. And then we connect the iSCSI server. Then after finding the disk, we enter fdisk-l. The disk information is displayed. The actual DEV SDA 11 gigabit is displayed. That means I have mounted the disk now. And after mounting it complete, do we need to format it? Let's look at the disk properties. let's see, the disk attribute is ext4, which indicates that the disk has been formatted. Therefore, we do not need to format the disk again, and we can directly mount the data. So again, create a folder as a mount point. At this point, I created the directory as mount send2 to distinguish. And then we mount it and check the disk. Now the disk is mounted. After the mounting is complete, we switch to the server and see how it accesses. Here we can see that the access information is changed from 1 to 2, 1.75 and 1.143. That is, the two clients can access the network. And then let's check the client 02 if there is anything in the directory. Here we can see that there is a send.txt file, and then we cat it. And the client 01 content displayed. So this data is synchronized. And then let's think of a question in the previous NFS practice. When we operate on 02 and 01, the other part can see it. So now if I create a file on 02, can I see it also in 01? Let's create a new file and write the content. And here let's write in 3 new. Okay, and then we can cat check the configuration is complete. But everyone, let's look at the data in client 1. Let's check it. We found that it had only a send.txt file and was not synchronized the data. And then if we create a new file in client 1, after the file is created, we go to 02 to check the file. It is found that 02 does not synchronize the data also. So at this point, we find that when I create the file on client 1 or client 2, the other part does not synchronize the data. However, at the beginning, 02 can find the paired data during the mounting. Therefore, you should think that these two methods are very different. When the second one are mounted, you can view the data, but after mounting is complete, the modification cannot be synchronized. And here, let's take a little test. If I unmount client 02 and remount it, will the content change? First, unmount. And then remount. Now that is remounted. And then let's go back to the directory and see what's changed. Here, the new file, new.txt file created by client 02 does not exist, but the file created by client 1 still exists. So it can indicate that there is no synchronization mechanism between the two sides. To solve this problem, we need to configure some cluster file system or distributed file system to solve the problem of data synchronization. Though there is some of our connections and usage about IPscan and iSCSI. So if we want to restart now, then our configuration is gone. So we need to set the auto start when the server restart. So first of all, let's go into the server and see how it works. First of all, the automatic startup files is also stored in etc file. So we go to etc directory and there is /tgt folder under the etc and there is a target.conf file in this folder. And we're going to edit it. We're going to edit some of the relevant startup files. The editing context is the information about the target, the disks, and network segments that are added during startup. So in this example, we added the name IQN.2024 is written behind the target, and the disk to be mounted is DEV VDB. Therefore, the backend storage is followed by the disk information. And then you need to configure the IP address and set the IP address can be accessed. So here you can configure a specific IP address or a network segment as described in the lab guide. And then we enter the complete character /target. Finally, remember to save and exit. In this way, you do not need to configure the target again when the system restarts next time. This is the configuration on the server. And then the iSCSI configuration of the clients is the same. You need to set automatic mounting. So let's take a look. Its configuration file is also stored in FSTab. And I'm not sure if you remember, but we have reviewed it once before. So first, let's go to edit this. And here, one thing note that your disk is SD. For me, it's SDA. And then I mounted it in the folder. For me, is mount SAN. And then the disk is ext4 file system and then default 0, 0. This is different from NFS, which is default _ underline net DEV. Because we are a network file system, so you need ensure the IP connectivity. And because my service work properly, so the netDEV ensures that the network is available, and then we mount it. Therefore, it's need to add netDEV, and then we save and exit. In this way, when the client is started, you do not need to manually mount the client. Well, the above content is our mounting and using automatic startup has been explained to you. And finally, let's finish to delete everything we have created before. And first, you can uninstall the mount, and here remove iSCSI as well. And then the same operation is performed on client 2. After unmounting both ends, we go to server to check. At this point, we found out the connection was gone. And then I'm going to delete the IP address as well. And here, when we bind, the bind is used here, and unbind is used for unbind. And then it gives a target ID for 1, followed by the IP address you want to unbound. For example, this is 1.75, and then this one is delete. Let's check the IP address of 75, which is gone. And then we remove 143. At this point, we don't have both the IP address. And then we delete the LAN. So as I said before, the creation time is new. So the deletion is delete. Then we query the result, shows that LAN 1 is lost. And finally, we'll delete our target again. And then we can check it. We found that the target is gone. So means we will clean it up. So that's all for the SAN configuration.
This section describes how to configure the target on the server and initiator on the client, verify service, delete service interactions, and clear the environment. That's all about SAN storage. In the next section, we will start with distributed storage. Thank you for watching.